So here's the problem from the book that corresponds to that problem out of WebAssign. And what I'm noticing out of this about this problem is that I'm not told the population standard deviation. I'm told the mean weight from the sample, so that's X bar. X bar equals 25.2 pounds, and the standard deviation from sample S is 4.5. So since this is a sample mean situation when we don't know the population standard deviation, we have to use the t-distribution to do this. So the point estimate, well, as before, the point estimate is just your sample mean. So our best guess about the mean weight of salmon in this river is 25.2 pounds. Now, but because of sampling error, we know that can vary, and we're going to come up with a couple estimates for that variation. So what you got to remember when you're working with the t-distribution, if you can do this by hand, you have to find the degrees of freedom to add that extra because you're working with some small samples. So you got to make sure you account for all the extra variation that come from small samples. So I went out to the t-distribution table out from the textbook, and I grabbed a picture of that. Okay, and let's see if I can move that, leave that so we can see it. Well, I'll leave it right here so we can see it. So I've got 19, remember it's n-1 degrees of freedom, and I highlighted these. So 19 degrees of freedom. I scrolled over to the 95 column and to the 90 column. So for part B, we need to remember that we're going to use a critical value of t of 1.729. And for part C, we're going to use t star equals 2.093 to go out a little bit further than to account for the, should be a 9.3. Let's fix that. To account for that extra variation when you're dealing with larger samples. I mean, with a larger level of confidence, higher level of confidence. Let me get the right tool here. 2.093. So then to get our standard deviation for the sampling distribution, we're going to take, so this is the S, SX, I don't know what we call it for this book now, but I know I've got to take S and divide it by the square root of the sample size. So I'm going to take 4.5 divided by the square root of 20. And on my calculator, what does that give me? 4.5 divided by the square root of 20. I'm getting 1.006. So that's my standard deviation for the sampling distribution. Now to get my margin of error for part B, I'm just going to take the 1.729, multiply that by the 1.006. So times 1.729. So that gives me a margin of error of 1.74, I'm going to go with. Then to come up with my confidence interval for part B, I'm going to take my sample mean, 25.2. I'm going to subtract my margin of error. That'll give me my lower bound. To get my upper bound, I'm going to do 25.2 plus my margin of error, 1.74. I don't know why I wrote 5 here. Okay. Now to get the 95% confidence interval, we're just going to take that higher, that upper t-score, the 2.093, and multiply that by the standard deviation, because that doesn't change for the sampling distribution. So let's see, 2.093 times 1.006. That's 2.11. A little bit more, and it goes to the higher level of confidence. So 25.2 minus 2.4 to 25.2 plus 2.4. Or why am I saying 2.4? 2.11. I can't read my writing. That's what the issue is. This is 2.11 to 225.2 plus 2.11. And that's that. Okay, based on your prior answers, are you confident that the mean weight of salmon is greater than 23 pounds? Well, let's see. My lower bound, certainly for the first one, I guess I should calculate that. 25.2 minus 1.74 is 23.46, so that's higher than 23 pounds, so that supports that conclusion. At least we're 90% confident it does. I mean, it's a little bit of some flexibility there. It could be wrong by 10% or 5% either way, right? Let's see, and then the last one is 25.2 minus 2.4, no, it's 2.11. That gave me 23.09, so that's also higher. So yeah, I'm fairly confident that we've got that average of 23 pounds beat. And why I was able to use the t-distribution small group, it's because they're telling me that this distribution is normally distributed. Okay, that's what lets me apply the central limit theorem. So I hope that helps you calculate this kind of confidence interval. Maybe before I go, since I've got the time, I'm going to grab use the applet there. In fact, why don't I write down some numbers here? And let's see, so n is 20, sample mean is 25.2. We've got a standard deviation of the sample, standard deviation of 4.5. And we want a 90% and a 95%, because I can encourage you folks to use the applet. So let me do this. Let's see, I'm going to stop this share. I'm going to go out to David Lane normal. Don't search David Lane, because you'll go to some white supremacist site. So David Lane normal. Then let me share this here. I'm going to share. Let's see, where is it? Here it is. So then my mean is, I'm on the wrong applet. Sorry about that. I'm going to go to Rossman Chance. One thing about live recording, here we go. Here we go. This is the one. So I've got one mean. I've got an n of 20. I've got an x bar of 25.2. I've got a sample standard deviation of 4.5. Let's calculate that. And then we're on a confidence interval. Let's do the 90% first. So that's that one. And see how easy that is? I mean, there's our answers right there. And this does the t-distribution and doesn't do a z-distribution. But now I'm going to do a 95% confidence interval, and there's our other one that we found. So it's a lot easier. It saves you from having to find a critical value of t. So I'm encourage you to use this, especially next week when we start doing tests of significance. Okay, important to make sure you select what you're working with. Here we're working with one mean. Okay, I guess I'll stop recording, and hopefully that'll help you do this.